So since my last video, I've watched anywhere from, let's say, 100 to 200 videos, and I haven't found any in which someone talks about electricity and uses the kind of perspective that I do or uses the kind of terminology that I do. What I did was in my electrical videos is I compared traditional ideas and terms such as single phase with my new terms, single cycle. In other words, I want to get rid of single phase because I think it's an inaccurate term, and I want to incorporate single cycle into alternating current terminology. One of the two really profound key points that I tried to make was this. Over the many, many years, people get the term phase and cycle mixed up. They got kind of jumbled up and forced together, and they kind of don't make sense. So I'll just quickly review phase. Phase is a distinguishable part in a course or a cycle. A cycle is a period in which something occurs. It's that simple. You have one part plus another part, and you get a whole. So in electricity, you get one phase plus another phase, and you get one cycle. Each phase is different. It's distinguishable. That's hard to say. So a phase then ultimately is an action part. It's a part of a cycle and something's happening, okay? I showed my picture I call a cycle graph, and you see phase A and phase B. The only difference is in phase A, current's going in one direction, and in phase B, current's going in another direction. And that's very important because you actually have two phases in one cycle. I stress that. That's a key point. It's very important to use the terms phase and cycle appropriately. In other words, concisely. All right? So phase A is distinguishable from phase B, but when you have a service like ours that provides 60 cycles per second, the phases are distinguishable, but the cycles are not. The cycles are not distinguishable. They're all the same. They just repeat over and over and over and over. They're not really distinguishable. That's a very important key point. Now, the other key point, the other profound point I tried to make was this. If you look at my drawing, which I call a transformer or a coil graph, you'll see a very primitive drawing of a secondary coil of a transformer. I showed that in previous videos. Now, the thing I tried to impress upon the viewer is, if you look up at the transformer, you think you see three separate conductors coming out of the transformer. You think you have three separate conductors. You would call this line 1, line 2, and this one you'd probably call neutral. Even though I call it a median, you'd see a neutral wire, okay? But that's an illusion. And that's very important for me to tell you this because I'm going to take it a step farther today, farther, and show you how we can look at alternating current and compare it to something else other than my new terms. In other words, something that's been in electricity has been around for a long time. We're going to compare it with something that already exists, okay? So the illusion then is you think you're seeing different conductors, but really all you really have here is this part of the conductor is just bent, and this is bent. All you really have is one conductor. It's just one conductor with the coils in the middle. It's coiled up in the middle. It's an illusion. This isn't really kind of what you think it is. So at any given moment here, let's say you're in phase A, current goes this way and only this way. Then current stops going this way and it goes that way, and that's what you would call phase B. I showed that on the cycle graph, okay? So all you really have is one conductor. You just have a bunch of coils in the middle. That's all it really is. That's the illusion part. And that way we can segue into the part that I up to this point haven't included. I want to throw it in. So in my videos up until this point, I haven't included this thought, this perspective, because I thought people would think it's a little goofy. But when I was reviewing this and watching other people's videos since my last video, I thought, well, wait a second. I keep telling everybody here that we have basically a single conductor, and at any given moment, current can go only one way, either this way or this way. Then I thought to myself, well, why don't we compare my new ideas with systems that already exist? So I'd like to talk about how my new ideas of alternating current and my new terms compare with direct current. All right, if you could just bear with me here. So I claim that single phase service, there's no such thing. It's single cycle. In other words, you have phase A plus phase B equal one cycle. I've said it 1,000 times. Each phase is distinct. It's distinguishable. The cycle itself is not distinguishable from the other cycles that follow, because there's 60 per second and there's millions and billions throughout the day. Okay? Now, one cycle is not distinguishable. It just repeats. That's all. The phases alternate. Current goes one way, then the other. You could say that the alternation provides the phases. You could say the alternation back and forth provides the phases. So if in a single cycle, according to my thinking, if you have two phases, A and B, you could call it dual phase, dual, all right? But double phase isn't good because you don't know if two of the phases are identical, so double's a crappy term. It's vague, all right? Split phase doesn't work. The phases aren't split, so you always end up with the phrasal term single cycle. Now, what if you compare it to DC, direct current, okay? Which I haven't done yet. So in direct current, the single direction flow of current provides the phase. I'll say it again. The single direction flow of current provides the phase. There is only one phase. There's only one phase. It only goes one way. In direct current, the phase is the thing in itself. In alternating current, the cycle is the thing in itself. I'm saying this clearly and succinctly to try to make a point that will help validate my other videos. In other words, with DC, the phase or the single direction flow of current is basically the thing in itself, the essence of the system. With AC, the cycle, all right, the two phases, all right, one following the other, is the thing in itself. So this is the beautiful thing I'm about to say, and you probably already figured it out. Direct current could, in essence, be referred to as single phase. Because why? Well, if you look at one of my primitive graphs again, here's your single cycle AC. Remember, phase A, phase B. In A, a current goes one way. In B, it goes the other. You see, two distinct phases. But look at direct current here. It's actually, it looks like it's single phase. Why? Current's going only one way, one distinct phase. Why is this not commonly referred to as single phase? Because right there it is. It's right there. Now, AC, alternating current, used because to help current travel, in other words, for the transmission of current over power lines and stuff, it's more efficient. you get greater power, faster, greater power. So AC, the benefit is you get the good power that you need, and it's nicely transmitted all over the country, all over the world, right? DC current's good for storage. You can store the current, and you can make cost-effective devices that use low voltage, and that's where DC comes in handy. But my third key point that I've been trying to make, and I'll wrap it up now, is we know this is single cycle. I've showed you this 1,000 times. You can't deny it. You can't dispute it. Well, you can resist it and fight it for a while, but eventually it'll catch on. People say, you know what? We have to change terminology here. But look at direct current. It's just one phase. Current can only go in one direction. It's one phase. And look at the primitive simple graph. Current just goes like that. It doesn't go back and forth. So I say that direct current circuits could be referred to as single phase. But AC, alternating current, it's either single cycle, all right, or in the more complicated systems, which I already showed, you could have triple cycle, and you have 3 cycles, and they are not out of phase. That's ridiculous. They are simply offset. They're just offset. Okay, so thanks for being incredibly patient, and I hope I made a good point there because it seems reasonable. Thank you, and good night.